Welcome to our next skill review video. It covers inequalities and interval notation. Our skill objectives for this one are one using interval notation. It's something I hope you're familiar with. If you're not, we'll get you familiar with it. Solve linear and polynomial inequalities, solve rational inequalities, and absolute value inequalities. You'll notice these are things that we kind of talked about in the last couple sections, so we'll be looking at those. Also, our conceptual objectives. Apply intersection and union concepts in terms of expressing solutions to inequalities. Understand inequalities can have one, none, or many solutions. Understand zeros and test intervals. That's going to be something that's key in terms of working on these. And then realize rational inequalities have an implied domain. The first thing we have to look at in this is some concepts that we have with this: interval notation, union, and intersection. Now, interval notation is a way to write an interval of numbers when we are looking at values between two different values. And really what happens, we have to determine if we are going to include the endpoint or not include the endpoint. If we are not including the endpoint, that would mean we would have a less than or greater than symbol. We're going to use a parenthesis with that value, with that endpoint value. If we are including the endpoint, then we want to use a bracket. So the general form when we work with interval notation is the left endpoint of our interval and the right endpoint of our interval. So if I look at the values of x from where 3 is less than x less than 10, in that situation, because I have a less than symbols here, I know I'm not going to be including the endpoints, so I would get parenthesis 3, left endpoint, right endpoint, and then the parenthesis again. In this next one, I have -2 less than y less than or equal to 4. In this case, we are including the 4. We're not including the -2. So my left endpoint is -2. My right endpoint is 4. Parenthesis with the -2 since we're not including it. And a bracket with the 4 since we are. Our third interval, 7 less than or equal to k less than 8. My left endpoint is 7. My right endpoint is 8. We are including the 7. And we are not including the 8. So I have the bracket and the parenthesis. And the last one, -1 less than or equal to x less than or equal to 2. That would be -1, 2. Those are our endpoints, and then we have the brackets. This first interval we have here is what's called an open interval because we are not including any endpoints. And when we are including both endpoints, we have a closed interval. These two would just be half open, half closed. Now, the other thing that happens with inequality, sometimes we don't see the two endpoints. In these first ones, it was real easy to see the endpoints. In this case, the next one I have is x is less than 4. So in that case, 4 is our upper bound. So we are taking every value that's less than 4. So our left endpoint in this case would actually be -infinity and 4. Since we can never get to -infinity, we always use a parenthesis whenever we use infinity. So in this case, it would just be the open interval from -infinity to 4. In the next one, we have x is greater than or equal to 0. 0 is our left endpoint. It's the smallest value that we have there, and we are including it. So I would have bracket 0 to infinity, parenthesis with infinity, bracket with 0. The other interval that you see a lot is what's called, when you see this fancy R, that means the real numbers, the real number line, if you will. And that is always going to be the numbers we express as an interval from -infinity to infinity. Now we also have union and intersection. Union means that we're going to take a set A and a set B, and we take the union, and we're going to put those into our set if a number is going to go in that union if it is in either A or B. If it's a member of A, it's in the set. If it's a member of B, it's in the set. If it's a member of both, it'll be in the set. Okay. The intersection, A intersect B, is where the values that go into the solution set there are only going to be the values that are actually in A and B. Let's take a look at a couple examples here. Set A is the closed interval from -3 to 2. Set B is the open interval from 1 to 7. And you can see those intervals graphed here. A union B is then going to be any number that's shaded between the two. So in this case, the smallest number that's shaded is -3. and up to 7. So it's going to be the interval from -3 to 7. We include -3, but we don't include 7. That would be the union, any value that's been shaded. The intersection is just the values that are common to both of them. In this case, both have 2, and they go down to 1, but not including 1. So the intersection here would just be the interval from 1 to 2, including 2, but not 1. Now let's take a look at a couple of linear inequalities for examples here. In this case, when you're working with a linear inequality, you want to go through and really get the x by itself. So in this first example, I have 4 minus 3x is greater than or equal to -11. So I'm going to subtract 4 from both sides. I get -3x is greater than or equal to -15. Now here's what you have to remember. Whenever you multiply or divide by an inequality by a negative, you must switch the inequality symbol. So in this case, to get x by itself, I have to divide both sides by a -3. And when I do that, I'm going to get x less than or equal to 5. And so graphically, this is what I would see. Now, a lot in the book we can use the bracket. The other thing you could use would be the closed circle, if you remember that. Another type of linear inequality is what's called a compound inequality. In a compound inequality, we are always it's going to be something with x in the middle, and then we'll have numbers on each end. Now, compound inequalities should always be written, final answers should always be written using just less than symbols. And really the purpose for a compound inequality is that we're really looking at values between two numbers. So in this case, I have 2 less than or equal to 4x minus 6 less than or equal to 18. Again, I want to get the x by itself. The one thing that's going to happen is I have to add 6 to everything. And when I add 6 to the 2, I get 8 less than or equal to. When I add 6 to this, I get 4x less than 18 plus 6 is 24. So I have 8 less than or equal to 4x less than 24. We divide by 4. I get 2 less than or equal to x less than 6. And that would be my solution. The next one we have to look at is polynomial inequalities. Polynomial inequalities are going to be something a little bit different than you have when you're working with linear inequalities. With linear inequalities, just like we did when we worked with linear equations, you could just solve for x and get your answer. With polynomial inequalities, you're going to have to factor. You're going to have to find the zeros of the polynomial, because those zeros are going to break that number line up into intervals. And once we have those intervals, then I can go through and choose a test value that I'm going to use to determine whether or not on each one of those little subintervals, if the inequality is true or false there. If it's true, we'll include it. If it's false, we won't. So in this case right here, I have x cubed minus 4x squared plus 3x is less than or equal to 0. So I've got to solve this one. So I pull out the factor of x, I factor it, and I find that my solution to the polynomial, it's going to be equal to 0 when x is 0, 1, and 3. Now, because this is a less than or equal to on here, or because it's including the endpoint on that, we know that we are going to be including the endpoints when we break this up. So I went through, plotted those values, 0, 1, and 3 on the number line, and that broke it up in intervals. My intervals, this first interval is from -infinity to 0. My next interval is 0 to 1. My third interval is from 1 to 3. And my last interval is from 3 to infinity. And we are including those as well. The test value is just going to be some number inside of that interval other than the endpoints. So in this case, when I go from -infinity to 0, my test value is -1. From 0 to 1, I don't have a choice. I have to use fractions, so I use 1/2. From 1 to 3, I could use 2. And from 3 to infinity, I use 4. And what I'm going to do at this point is just determine, is the inequality true or false? So when I put -1 in for x, I know this is going to end up being -1 times -4 times -2. And that is going to be equal to a -8, which is less than 0, so I know it's true for that interval. So that means when my solution here is going to include the interval from negative infinity to 0. When I put in the 1/2 in for x, that's going to be 1/2 times 1/2 minus 3 is negative 2.5 times a negative 1/2. And in this case, I have a positive times a negative times a negative. That is going to be a positive number. So this is going to end up being greater than 0, so it's going to be false there. When I plug in 2, I will get 2 times a negative 1 times, when I plug 2 in there, it'll be a positive 1, which will equal negative 2, so that's less than 0, so it's true there. So I know I'm going to include the 1, 3. And when I plug in 4, I get 4 times 1 times 3, which that is equal to 12, which is greater than 0, so it's false there. So in this case, my solution is just going to be the interval from negative infinity to 0 union the interval from 1 to 3. If I look at it graphically, it's going to be this part here, shaded. And then here, here, shaded there. With the rational inequalities, we have to do the same thing, something very similar to what we did with the polynomials, but we have to realize that we're going to be dealing with top and bottom. When we got to identify when the top is 0 and when the bottom is 0, because those are going to be places that are going to break this thing up into different intervals. So in this case, for this particular problem, I have x minus 4 over x squared minus 4 is greater than or equal to 0. If I factor it, I get x minus 4 over x minus 2 times x plus 2 greater than or equal to 0. I need to determine what values of x are going to make the top and the bottom equal to 0. My top is going to be equal to 0 when x equals 4. So I know when I put 4 here. Notice the 0 up here, because that means that when I put 4 in for x, the result of that is going to be 0. So that is a possibility that takes place. The denominator is equal to 0 when x is positive or negative 2. Now when the bottom is equal to 0, that means the fraction is undefined. So when I place the negative 2 and 2, you see I put the u's up there. So I make sure I remember I cannot include 2 and negative 2 into my intervals. So these three values break up my number line up into 4 intervals. One is from negative infinity to negative 2, another from negative 2 to 2, and then a third from 2 to 4, including the 4, not the 2, and then from 4 to infinity again, including the 4. My test values. For the first one, I use negative 3. Next one, I put 0, then a 3, and 5. And when I plug those back into the original problem, when I put a negative 3, I get a false statement. When I put a 0 in, I get a true statement. When I put 3 in, I get a false statement. And when I put 5 in, I got a true statement. Pause the video, make sure you and verify that otherwise. And then that means, and once you're comfortable, then we can go on. But your solution on this is going to be the interval from the open interval from negative 2 to 2 union the interval from 4 to infinity, including 4. The next that we have, the last type of inequality we have, is the absolute value inequality. Now what you have to remember on here is the translations that take place. Anytime you see, when you see a less than or equal to, that means we're going to be dealing with a compound inequality. So if I say the absolute value of x is less than a, that means x is going to be between negative a and a. When I use a greater than or equal to, that means we're looking at what's called an or statement. And really, because we're looking at either values of the solutions are going to be bigger than this number or smaller than another number. So in this case, the absolute value of x is greater than a means x is greater than a, or x is less than the opposite of a. And the same thing with the greater than or equal to. Let's take a look at an example here. In this case, I have the absolute value of 6 minus 5y is less than 1. So because it's a less than, I know I'm going to have negative 1 less than 6 minus 5y less than 1. Solving that, I subtract 6, I get negative 7 less than negative 5y. less than -5. Divide by -5. And remember, we switch the inequality symbols when I do that. So I have 7 over 5 is greater than y greater than 1. But remember also, compound inequalities should always be written with a less than symbol. So that just means I have to switch this around. So I get 1 is less than y less than 7/5. So my solution on this is just going to be the open interval from 1 to 7 over 5. So this now does conclude the video dealing with inequalities, reviewing inequalities. Again, make sure you're comfortable with each of those, especially the idea of the test intervals, because that again is going to come into play, and same with working with absolute values. So with that, if you have any questions, make sure to note them and ask them in class.